Today we're going to do Bayesian updating, which is to say we're going to be using Bayes' theorem to learn from data.
Suppose in this MIT mug I have dice of two types, 4-sided and 20-sided. I'm going to randomly pull out a die, roll it. All right, I got a 1. Which type of die do you think I randomly chose? OK, that was actually what I had in this cup. Does this change at all your analysis of which die you think I rolled and got a 1 with? So this is the first board question. All right, I want you to practice making the table Jerry showed you. Make one for if it were 13. Make one if I had rolled a 5 instead, or do the same question if I had rolled a 9. And in each case, compute the posterior probabilities of each of the 5 types of dice.
You knew it was a 20-sided die.
Yeah.
All right, what about if it's a 5?
Yeah.
But that's it. But you see how that captures it very nicely in a table, all of your intuition.
Your beliefs have changed based on that about the probability that you have each of the 5 dice. So if you take that and you use that as your prior here, then the likelihood, multiply and sum.
There we go.
That should give you.
I like that.
People learn better, in fact they learn best when they construct their own knowledge, when they're active in the construction of knowledge, rather than going and sitting and listening to passive lectures.
What we're going to do is we're going to run this motor here, and the red button on your apparatus.
Teal is one of the formats, let's say, that grew out of the extensive body of research from physics education researchers.
It's the idea that if you do it yourself in front of someone who can watch you do it and give you feedback on what you're doing, then you're more likely to learn.
It's a studio-style, studio-based method where the classroom consists of round tables and students sit around it and they learn from each other as well as the instructor.
We also do in-class problems where we have students work more difficult problems at the board, again as a group, so they're able to talk about it with their peers and figure out what's going on.
Just to make sure everything's clear, I want to ask you a question. But to kick off the idea of working together, I'd like you to think about this question with your neighbor. So before thinking about this question, everybody stand up. Introduce yourself to your neighbor. So now I'd like you to each discuss with your neighbor the list that is best represented by which of the following figures, 1, 2, 3, 4, or 5, none of the above. And in 30 seconds, I'm going to ask everybody to raise a hand with the number of fingers indicating the right answer. You're allowed to talk. That's the whole point of having a partner. I'd like everybody now to raise their hand, put up the number of fingers that show the answer, and I want to tally. Fantastic. Everybody gets it.
The first problem is right here. I'm going to give you a chance to practice doing a proportional derivative controller. And I've actually written the specifications directly in terms of phase margin and crossover frequency. So you can either imagine that that's the way the specifications are given, or that we started with a rise time and peak overshoot and derive these. So your goal is to design a K of S that meets these specifications. So if everyone could, please form up in groups of 2 around the room as usual. I'm Steve Hall. I'm the instructor of 1606, which is Principles of Automatic Control. It's a junior level classical control class, which I've been teaching for about 6 years. Recitations in 1606 are a little different than most recitations at MIT. In most recitations, the instructor would present a series of problems, maybe related to the homework, just to give examples of how the problem should be worked. Sometimes they might have students try some themselves. In my recitations, it's much more active. Students are always standing up. We work at the board, usually in groups of 2. They're working problems, and the TA and I are walking around, helping when we can, answering questions when students have them, and generally just coaching, trying to help the students understand what they're doing and solve the problems. It really is a chance for students to understand what they know and what they don't know, and to exercise the skills that they've learned in the class. And if they have problems with those skills, it's a chance for me to help them learn them better.